right, so we're going to go into our demos now. So we'll start off with modular authorization with Raghd from our team. So Raghd, I will let you go ahead and take over.
So if you were here in the last community call, you may have seen me try to demo this and failed. Hopefully this time it'll be better. Um, I'll just quickly reintroduce what we're working on. We're trying to bring access control into OpenFGA. So to allow you, right now, any API token, any client ID you have has access to everything. So one of the things requested a lot is like, no, I want to have my to restrict whether to do maybe just reads or to be able to write specific things. And what better way to have access control than to use OpenFGA? So we're using OpenFGA underneath the hood to power access control for OpenFGA. And I'll basically quickly go through what we're doing. Note that this is right now, or will be going out in an experimental phase without like the bells and whistles of how to bootstrap. So bootstrapping might be a bit not quick and easy. Like we might have a few steps. So that's just only in the experimental phase as we collect more of your feedback, and definitely we'll be looking for your feedback now and as you start using this more. Quickly for now, enabling access control will require you to have OIDC set up. So if you have no authentication, I mean, obviously, if you have no authentication, you cannot enable authorization. But also, if you use API tokens, we won't like you can't enable access control. If you have OIDC set up, if you have client IDs, that's when like right now being able to enable access control works. For the sake of the demo here, I already have enabled OIDC. I have like a random issuer. This is using auth0. You don't need to, whatever IDP you're using works, but you do have to enable OIDC. And again, for the sake of my demo, I've created two client IDs, kind of a root management client ID that I will use to kind of create stores and to give other clients permissions. And I'm going to have a per project client ID that I'm going to use for specific projects. You'll be able to see the client ID secret here. So I'm going to be using these two. You'll see me flip between them, the project and the root config. Ignore the secret, I'll rotate it after. So first of all, what do we need to do? Importantly, because we don't have bootstrapping in yet, you have to have access control disabled. Otherwise, you'll be locked out. So if you say access control enabled without doing the bootstrapping parts, of course, you will not be able to access. It is experimental, so you have to turn on the experimental flag. And sorry, if you can't see what let me zoom in. So you're just going to say, okay, enable this flag. This allows you to work with access control. It does not enable access control. This flag will be going away once we have this in production, and these are the actual controls you'll be using. So right now, I have access control disabled. Let me spin up OpenFGA. Okay, great. Again, I have these two client IDs. So first things first, I want to create the model and the store I'm gonna use for access control. And this is what we have. Basically, we have a system and an admin on the system. This is to allow you to have that root client, which will be able to do everything. And currently, only the system can be able to create, store, and list stores. You want to have more people be able to list stores, you can modify this up to you. So this is a sample model. What we require is it must have the system type, some of these types, as in the can call create. All the cans you see here are required. as well as the system. Basically, that's it. Everything else you can play with. But again, so this is the system. This is the model we're going to be using for our FGA on FGA. We also have a module. You've probably worked with, or maybe you've worked with the modular approach where you can split your model across modules. If not, we'll link in the chat in a bit, like how to do that. But basically, our CLI gives you the option to break your DSL down into separate modules, allow it to assign code owners per module. This takes that to the next level. This uses the modules you're using to now give client IDs access to write specific modules. For example, we're going to use like Atlassian as an example. You may want to give the client ID for the Jira team to be able to write modules related to the Jira, but not tuples related to Jira, but not tuples related to Confluence. So each team will be able to only write tuples that they are owners of. And for onboarding, we're going to say this root client ID is going to be the admin. So this is where we're going to do to initialize and start using access control. So again, let's start, and we're going to create the root store. Note, access control is right now disabled. So we're just starting with this. So first of all, we're creating the root store ID. We're going to root store. We're going to create a store for this random project, Atlassian in this case. We're going to create the model for access control. So this is the one writing the root model as well as this tuple. So we just did that here. Now, all we need to do is turn on access control. We're done. We're done bootstrapping. We need to turn on access control. So let's go back to the Docker Compose file here. We want to enable it. This is the store ID, and this is the model ID. And let's restart the server. Okay. Now, we're going to try to get the Atlassian store, so the store we created for Atlassian, with our root client ID. Again, the one that's admin on everything. It's admin on everything, so it'll be able to do that. When we try with the Atlassian store ID, and sorry, I'm using Atlassian. They have no knowledge of this project. It's just an example. But when we use the client ID we're using for this project, we won't be able to get it. We don't have access, basically. So what we're going to do is use the root client, the one that's admin, to grant ourselves access. And we do that by writing a tuple that says application, this client ID, which is the project ID, can read this, is a reader on the store. What is a reader? A reader can do all the reader things here. So it can call the get, check, expand, all these functions. So, sorry. That is my problem because I did not do this first. Okay, so we just granted this client ID access to this store only as reader. Let's try getting the store again. Also, as a project. We're not root anymore. And now we have access to get it. We'll try writing. So this project wants to write a model to continue. It fails because we only have reader access. We haven't given ourselves access to write the model. So let's do that. We can now write the model. Okay, now that we're done with writing the model, let's run some checks. note that we are readers, so we should be able to run some checks. And yeah, it works. This is false. We're trying to check if Anne is a member of this organization. Let's say we wanted this check to return true. What do we need to do? We need to write a tuple. That fails because we don't have access to write a tuple. We're both a reader and a model writer. We're not allowed to write tuples. Let's just confirm for this other tuple. Can we write? No. So what we're going to do here is grant permission not to write all tuples, just to write tuples of a specific module. So what we're saying here is this project we have, this project client ID, is now a writer not to the whole store, not to all the tuples, only to the modules of type Confluence, the modules that are Confluence. And we wrote that. So if you go back to, I should probably have gone through this, but this is the Confluence module. So this is what we're working with. So, sorry, not sure what that is. The space is of type Confluence, and let's versus organization is of like the module core. And let's see how that changes things. We granted ourselves to write to this space, to the Confluence. So let's write that tuple, and it's working now. Let's try again to write to the core, which again, organization is of module core. It's still not working. So we now have access to write only particular tuples. And of course, we can change that by saying, all right, now you have this one. If you want to grant yourself access to write all tuples, you don't care about modules, you can still do that. And can we write? Yes, you can write again. That was, sorry, not a quick overview, but I see some people have questions. Someone has their hand raised.
Yeah, we had two. So with the person who has their hand raised, you're listed as iPhone.
I'm not able to see clearly. It's not letting me zoom in.
Oh, sorry. Is that everyone or?
I don't know. It's just, I can't really see it.
Yeah, it seems to be on an iPhone, so probably you need that.
So is that the issue?
No, it's just probably and he's sharing his desktop, right? So it's probably too small to.
Yeah, maybe scaled down.
Yeah.
Okay, let me give that a try. Thank you.
Gerline has a question. If I leave out the model ID, does it pick up the latest one? Yes. Like this normal functions underneath the hood as a normal OpenFGA instance. But that comes with our normal problems. If you don't provide a model ID, you're going to have some performance problems because we're not able to cache the model. So when you give a model ID, we can cache it, so you have better performance there.
But is it only on the startup or on every request you are going to fetch the latest model?
So no, it is not on every request, but on every few requests. So because in latest, if you keep looking for it, at some point we switch it. So it's not like fetched once and then stop. It will be cached a bit, but it will keep changing. Again, just like normal OpenFGA installation, there's nothing different.
I have one more question, if you don't mind.
Yeah, absolutely.
So correct me if I'm wrong, if I understand this correctly. The way to implement access control at the tuple level, for example, if I want one of my clients to only be able to perform some actions on this specific type, the way to do is using modules.
Yes. Yeah.
Okay, so it's at the module level, not at the tuple level. So whatever, if there are multiple types in the single module, the application will be able to operate on all of them.
Yeah. And that's feedback we want to hear. So if that doesn't work for you, or you prefer more fine-grained access, even, yes, let's talk about that. This is our initial implementation, and we do want to evolve it as we get more feedback. We are releasing it in experimental mode initially, without the bootstrapping and without giving you even like the model. We're going to give you this example model just so that you can tell us, okay, what works for you, what more do you need, and how would you prefer to bootstrap it, all these things. So definitely we're looking for feedback.
So on our end, we are going to implement something where each client, whoever calls to OpenFGA, like it goes through our run service. So each client will have like an allow list of types they can play with. So this is exactly something we are looking at. We are looking at tuple level access control. So I think even with modules, that is possible if you kind of split the modules. Like you have to create so many modules, but that's fine.
Yeah.
Yeah, in general, the way we're thinking about it is that if you want to have a specific client permissions to write to a specific set of types, is because those are the types that application owns in a certain way, right? And combine and defining that as a module is kind of a good abstraction to define those. Maybe we see scenarios when, that is not flexible enough, and we can always add another label, which is per type, right? So the tuple will say you can do it this per type. That is possible. And in this case, it will imply that whenever we do the check, and we kind of need to take that into consideration, right? But it's not just the module, but the type, but it's totally possible. Okay.
Yeah, in a future iteration, assuming like this is what we want to do, we could do something like this, like where we introduce a type and like continue down this path.
So for this, like you need to enable OIDC, right? There's no other.
Yes, I mean we considered for API tokens. Right now, we really don't want to store API tokens in the database. So if we do something for API tokens, it'll be like we need to introduce something to identify them. So there's an identifier that's different from the token itself that you can store in the database. And that's why we don't want to deal with API tokens right now before we validate everything else. And OIDC makes this easier. One more thing to say, where are we getting the client ID? So you have OIDC, but where are we getting the client ID? We're adding a configuration to say you can choose which claim to use. So if you want to use user ID instead of client ID, you're free to do that. You can, by default, we're going to look at client ID in the claim and then AZP in the claim, because there's two RFCs, each one claims something. So we'll use those. You'll be able to pass in configuration an array, and we'll go in order. So if we can find the first in the claim in the token, we'll use it and keep so you can say like, oh, I want to use user ID if available. If not, client ID. We will use that.
Okay, I'm not gonna take all of the time, but for here, like, so the way we use it is OpenFGA is behind a service, and only that service is allowed to talk to OpenFGA. Every other services goes through that service. So I don't think OIDC makes sense in this case. We use API tokens. It would be nice if some way that service can provide, okay, hey, like this is the client that is trying to do something. Here is the ID.
That's very possible. Yeah, we can talk about like outside, but yes, basically you'll have to implement your own. Sorry, I don't know what's happening on the. Someone is.
I back to.
I'll stop sharing. So you'll be able to. I mean, if you're implementing your own checks, you can use contextual tuples to provide the client ID in that case, or something like that. But we can definitely chat more about it. Like,
yeah, but that's something that we kind of, it makes sense, right? So if you're using API tokens, we should be able to let you use the feature, right? So that's something that is part of a future iteration of how we handle that. Another one is, how do you want to handle these permissions between like clients and modules and permissions? And one scenario there is you want to handle this with configuration, right? So you have like a YAML file that says this client can perform these actions in the store instead of the API, right? So how would it make the bootstrap of that work, right? Because like we need to kind of create a store somehow with that content and use it for authorization. So we're also discussing a few alternatives of how to manage that.
That actually would be very nice because, like, if you want to take like an overview of what client is allowed to do what, a configuration file definitely helps with that instead of going to the database listing out everything.
Yeah, and we still need to load that in a store. And if you're using Postgres, right, we need to when the service starts, we need to kind of create store and put that data. The issue is that we can start a lot of OpenFGA services at the same time, so that will create a problem, right? You might create multiple stores and have some kind of case conditions there. The other way we are discussing it is, what if we let you specify for a specific store, you use specific storage adapter, and we use the memory store for this one. So now each module just loads store with that data, right, in memory, and doesn't go to the database to do this check. So it's going to be faster, and we don't it's easier to address that. But today in OpenFGA, we don't have a way to say the storage adapter is per server, right, not per store.
Yeah.
So we need to somehow find a way to configure.
That makes sense. Because the good work, man. Like, props to you.
Thanks.
Yep.